This is Mr. Caton. I'm here to talk to you about coordinate rules for reflecting things on the coordinate plane. Up here we have image ABC, and it's being reflected around the line y equal to 1. So that's getting flopped down. So as I said, it's getting flopped down. Notice it's important that if A is the farthest away from your line of reflection, A prime will also be the farthest. Notice this is like having your nose right in the mirror C's right on the line of reflection, so your nose, you're actually going to see a reflection. It's at the same point because it's being reflected around that line M. If you stick your nose against the mirror, try that tonight, you'll see that it's still there. Anyways, here's some rules. If we're reflecting around the x-axis, the only thing that's going to change is your B value. It takes the opposite sign. If you're reflecting around the y-axis, AB, your A value will change. It will take the opposite sign. It gets a little trickier when you're reflecting around the line y equal to x. A little review, line y equal to x is 45 degrees sloping up that way. What'll change then, it flips your AB and makes it BA. So your x and y values change position. So your x value becomes your y value and your y value becomes your x value. A little parenthesis there. If you're reflecting around the y equal to negative x, that looks something like this. Going up to the left, the AB values are going to flip and change sign. Okay, so those are the coordinate rules for our basic reflections around the x-axis, around the y-axis, around the line y equal to x, and y equal to negative x. So let's try a couple examples of those. First one, pretty straightforward. It says reflect the following image around the x-axis. That means we're going to rotate it down. So this is going to pick up at the negative. So if this is point 1, 1, A prime is going to be 1, negative 1. So it's just going to be there. Notice it's the same distance away from the x-axis. This is 3, 4. We're just going to switch. So we get a 3, negative 4. That'll be B prime, 3, negative 4. Our y value, here it's changing. So here we have 5, 3. So C prime is going to be at 5, negative 3. And we get the same image reflected over the x-axis. Okay, in this example, where the endpoints of AB are 3, 2, and 4, 1, they're graphed here already. They'd like us to reflect the segment in the line y equal to x. So the line y equal to x is this line right here. Has a slope of 1, a y-intercept of 0. So we're going to reflect it about that, which means it's going to get transferred up. So it should be the same distance away. So this point should be the same distance. And what were the rules? Oh, we said if we're reflecting around the line y equal to x, AB is going to go to B, A. So in this case, 3, 2 is going to 2, 3. So 2, 3, that's that point there. And the other point, 4, 1, is going to the point 1, 4. So that gives me A prime, and 1, 4 is there, and there's B prime, and that gives us our reflected line. And you can see it, my line y equal to x isn't going exactly along that. Should be going through these points right here. And the nice thing about that is you can see this distance here will be the same as that distance there. Right, these two distances here should be the same from your reflected line. Let's try the next problem. Okay, last example here. So this one they're asking us to reflect in the line y equal to negative x, which means we have a slope of negative 1, and it goes something like that. So here we had x, y going for around that x, y equal to negative x. It's going to go to negative y, negative x. They flip and take the opposite sign. So 3, 2 is going to go to negative 2, negative 3. And 4, 1 is going to go to negative 1, negative 4. And it should be the same distance away. So negative 2, negative 3. That'll be my A prime. And negative 1, negative 4 will be my B prime. And now I've reflected it around